A ray is a straight line extending from a point. Okay, basically it's half a line. And when we talked about the line, we said the letter order didn't matter, right? So if I had line AB, I could name that either AB or I can name that BA. These were both all right. But when we talk about a ray, this point where it ends has to be the same as the point where it ends when you're naming it. So I can't call this ray BA because the A has to be the side with the no arrow. Okay, so this is really important. With a line, it doesn't matter because lines go two directions, but with the ray, since it only goes one direction, you want to be really careful with that. Okay. Then we have a segment. And when we draw a line on a piece of paper, what we've called a line in the past, where you just go, oh, look, I drew a line. No, really you didn't. You drew a line segment because lines are infinite. A line segment is just a chunk of a line, a small piece of a line, and it's finite, which makes it measurable, if I could spell. That says measurable. And you can either use the word segment and call it AB, or you can draw a line piece without arrows. And with a segment, the order doesn't matter either, because you have two ends, so that's okay. It's only with the ray that it matters. And then you have the end point, end. Pretty self-explanatory, I think. And finally, we have length. We can measure a segment has length. But a line and a ray do not. So lines and rays are unmeasurable, segments are measurable. Okay, so we have, do you guys know the prefix co? So like cooperate, cohabitate. Co means together. So to cooperate is to operate together. To cohabitate is to live together. So we have in geometry co. We have collinear, which is to be on a line together. Okay, and it doesn't have to just be, you know, one or 2 points on a line together. You can have, you know, infinite collinear points, because if you think about it, a line is a set of infinite points and they're all collinear. So any number of points can be collinear. Okay? But in order to create a line, you have to have at least 2 collinear points. So 2 is the minimum. There is no maximum. So A, B, and C are collinear. And then we have non-collinear. Well, if collinear is on the line together, then non-collinear is not on a line together. So if we look at this, we have A and B and C. Now, I could conceivably draw a line between A and B, and they would be collinear. And I could draw a line between like A and C or B and C, but there's no line where all 3 of them are going to be on that line together. Does that make sense? So the 3 of them are non-collinear. And we also have coplanar. So just like collinear, coplanar, together on a plane. then we have non-coplanar, which you have A and B are coplanar, they're on the same plane, and then C is over here by itself, floating off in space, not on the plane, so it's not coplanar or non-coplanar. And we can have coplanar lines. So these two lines are on the same plane, and non-coplanar lines are not on the same plane. Now another example of non-coplanar lines is I could have this plane, isn't that pretty? And I could have one line that's on the plane, and I could have another line that kind of like cuts through the plane like that. This intersects the plane, but it's not coplanar with the two lines are not coplanar because they're not both floating on the plane. Like they have to be as if you drew them on a sheet of paper. I can't draw one line on a sheet of paper and then take a pen and say that's the other line and stick it into the top of the piece of paper and say they're coplanar. It doesn't work. They both have to be lying on the plane. Does that make sense? Just checking. Are things that we accept as true, but they don't have to be proven. Okay, so these are postulates. We just accept them as true. All right, so a line and a plane each contain an infinite number of points. Well, when we described a line and a plane, we described them as a line being a set of infinite points strung together going in two directions, and then a plane being a set of infinite points, you know, flat. So we accept that by design or description, they are infinite points. So we accept that they contain infinite points. Okay, for any 2 points, there's exactly one line containing them. Okay, so if I draw any 2 points, I can only draw one line to connect those points. And a line, when we say line by definition, we mean straight, you know, not a curve. And now granted, I'm not going to draw this straight because I'm not good at that, but a straight line. Pretend that's a straight line. Okay, so there's only one line that I can draw that will go through those 2 points. I can't draw any. I could draw some curves, a bunch of different curves and angles and things that connect those points, but there's only going to be one straight line that can connect any 2 points. If I have 3 points that are not collinear, so they're not on the same line, okay, I can't draw a line that will connect those, but there will be exactly one plane that can hold them. And we draw a plane like a parallelogram, so like that. And if 2 points are in a plane, then the line that contains them is also in the plane. So if I have this plane, and I have 2 points on it, and I draw a line, well, if the points are on the plane, then the line is also on the plane. And this is kind of why we just accept these as true, because if you think about it for a second, you go, well, yeah, that makes sense. And then if 2 planes intersect, they intersect in exactly one line, and I had that picture, oops. I'm not very good at drawing intersecting planes, but we got one that comes like this, and we got another one that comes over here like that. And when they intersect, it's a line. So we'll use these 2 pieces of paper. Okay. If I take this piece of paper and it's one plane, and I take this piece of paper and it's another plane, and I intersect them, can you guys see how it would kind of make a line? Okay. Probably easier to visualize than that thing that I drew down there. Didn't major in art, majored in math. I know. in general, and I'm not saying this is true of everyone, but in general, people like to do the least amount of work in order to get to the solution to the problem. As a whole, we're rather lazy, which has driven technology. Nobody wanted to carry a big stereo, so they created a cassette that you could carry, which that was too much to deal with. It was too big. So then they created a CD, too much, then MP3. And now you've got like your MP3 player is, you know, the size of a piece of gum. Carry it with you, you know, because we didn't want to carry stuff. That sort of carries to everything that we do. We do math problems and we want to do it in the least amount of steps possible. We want to write down the least amount of stuff possible. But when it comes to geometry, taking the time to draw the picture is going to be really helpful. Because if you draw the picture, a lot of times that will, by just looking at the picture, will show you how to set up the problem to solve it. And it'll make it much easier than trying to visualize it in your head. So we draw pretty much everything. Not well, but we draw it anyway. So if I want to talk about point Y, which is on line PQ, which is in plane T. Just reading that sentence maybe is not the easiest picture to visualize, but I can draw it. Okay, here's plane T, and I need line PQ. And it just says point Y is on line PQ, so it can be anywhere. But because I was able to draw that, I now have a foundation to work with, because if the next part of the problem asked me or gave me some information about the length of, say, PY in relation to YQ or something, I would now know where to label things and set it up so I could solve for whatever I needed to solve for. So it doesn't take that long to draw the sketch, but that picture is much easier to deal with than that sentence. Does that make sense? So I know the tendency might be to not want to draw the pictures, to just get through it, get it out of the way. Take the time to draw the picture. It will make a big difference. Okay, so let's look at this. Okay, there's a 4 under there. For example, the symbol LM tells us there's a line which contains the points L and M, and it'll look like that. Okay. Or it can be, you know, up at an angle, or the M and the L could be switched. It doesn't matter, just so long as you draw a line. It has 2 arrows on the ends, and there's 2 points on it, and they're L and M. Okay. So on this one, we're going to answer 2 questions and sketch 2 pictures. So I would like you guys to try these just in your notes, and then we'll go over them together just to make sure like everything's clear. So for the first one, a statement that is accepted as true without proof is a postulate. Okay, now your picture may not look exactly like this because it didn't specify where the points had to be. Just so long as you drew a parallelogram with a W in the corner, and then the Y and the Z need to have dots. If they don't have dots, then it's not clear that they're a point, so you need to make sure you put dots. But other than that, they can be, you know, sort of wherever. Questions on that one at all? Okay. True or false? False, yes. They intersect at a point, because you can never intersect bigger than you are, right? And then 2 lines that intersect at point H, you could draw any 2 lines going in any sort of direction so long as they hit, and there's a point, and you call it H. right, so distance, we have the extent of space between two objects or places. Now, distance can be something that has like a unit that's actually measurable, miles, feet, inches, or it can be sort of a theoretical if we talk about the space between two numbers. If you talk about the distance between 1 and 2, the distance is 1. It just doesn't have like a unit. It's not like 1 inch, it's just 1. And the distance between 1 and 3 would be 2. It's like the number of spaces between the numbers. Okay. Well, that shouldn't be in here yet, but okay. Congruency is when you have figures that have an identical shape or and size. They have to be both the same shape and the same size. And if they're basically identical, they're congruent, and the symbol is an equal sign with a little squiggle over top of it. And from now on, if you don't ever want to write the word congruent again, you can just draw this little symbol. Bisect is to divide into two equal parts, which are halves. A segment bisector cuts a line segment in half. And it can be a point, a line, a segment, or a plane. If it hits that center part and cuts that segment in half, it's a segment bisector. We have coordinates. Coordinates, we are used to the coordinate plane. You guys know these, the XY axis. This is axis X, this is axis Y, and there's the point out there. And it's an ordered pair, X, Y, whatever these numbers are. Okay, so the coordinate is also an ordered pair. And it can be any letters, but we usually use X, Y. Oh, wow, I can't pause that way. Hold on 1 second. Apparently that doesn't work. Number line is a visual representation of the order of numbers. And when we talk about a number line, you guys have seen these. We've got a 0 on there somewhere. And we just keep going. And number lines can be used to find the distance between numbers. Okay, to measure is to ascertain the dimensions, quantity, or capacity of an object. Okay, dimensions, yeah. Yeah, of course. Dimensions is usually lengths or length related, like length, height, and width, sort of a thing. Quantity is just the number of them. Capacity is related to volume. Lengths, this is also areas. It's not very pretty, is it? Midpoint. Midpoint is a very specific point on a line. It is the point at the middle or center or equally distanced from the ends. Okay, so if I have some line segment AB, and I say that this C is the midpoint, that's kind of my abbreviation for midpoint. This distance here, so let's say it's 5 inches, or sorry, the length here would be 5 inches, then this length also would be 5 inches. Those distances are going to be equal. Okay. And yes, I'm defining a ruler, and no, you do not have to write that down if you don't want to. A ruler is a thin strip with a straight edge and markings and whole and fractional units of length used to measure things. And I had to define a ruler for you because we're going to have a ruler postulate. So in order for the ruler postulate to be valid, we have to have a working definition of a ruler. But I know you guys have all used a ruler, so you don't have to write that down if you don't want to. Okay, so again, postulates that we accept as true. The ruler postulate states that the points on a line can be paired one-to-one with real number coordinates. So what this tells me is that if I take a line and I connect, it's a connection of points, and I just look at them, I can say that they represent numbers. Okay. And then the distance between the 2 points is the absolute value of the difference of their coordinates. Well, if you always subtract the smaller from the larger, you don't really have to worry about the absolute value. But distance has to be an absolute value. Do you guys remember absolute value is always positive? Distance has to be positive. You can't go negative 15 feet. I can go 15 feet forward, or I can go 15 feet backwards, but it's still 15 feet. So that's why distance is always positive. Okay. We have the segment addition postulate that says if B is between A and C, then AB plus BC equals AC. And that, if you draw it, okay, I have A and C, and B is between them. Well, here's AB, and here's BC, and if I add them together, I get the whole thing, right? So that's how this works. AB plus BC equals AC. I can add the two pieces to get the whole. And then we have a midpoint postulate, which says that a segment has exactly one midpoint. So if I have some segment PQ, okay, the midpoint has to be equally distanced from the end. So if this distance equals this distance, I can only have one midpoint. I can't have any other point that these two distances will be the same. Okay. Now when I have a midpoint, if this distance is x and this distance is y, they'll be equal to each other. Okay. When I have segment, if this is x and this is y, you'd add the two together to equal the whole thing. Does that help? Okay. No. Find the distance between -3 and 7. Okay. You can do it using absolute value, or I can take the absolute value and I can find the distance between them that way, and the distance is 10. If you use absolute value, it doesn't matter what order you put the numbers in. You always just take the difference of them and then take the absolute value of it. Or you always take the larger one and subtract the smaller one. So negative 3 is smaller than 7. So I choose 7 minus negative 3. And you guys remember what happens with the double negative? It becomes positive. See, he's happy. So it's 10. Now, if you get a negative answer when you're trying to figure out distance, just double check yourself. Maybe you did negative 3 minus 7 and you came up with negative 10 and then go, oh yeah, it has to be absolute value. Okay. You can also do it on a number line by counting. You just count the number of spaces you have to go. If you want to draw a number line, you can do that. Any questions on that part? Okay. We can also use the segment addition postulate to find the lengths of segments. So we have this figure here. And I want to find AC. Well, AC is AB and BC. So I add them together. 6 plus 2 is 8. I could find AD would be 6 plus 2 plus 7. I could find BD. It would be 2 plus 7. Does that make sense? Okay, so you just find the ends and then add up all the numbers between them. Good? Okay. We can also do this where we have the midpoint. If Q is the midpoint, that tells me that this length here is the same as this length here. If this is 2x minus 5 and this is x plus 3, those are equal. By drawing the picture, what I normally do is I say midpoint with that middle point. I always label it as a midpoint if it's a midpoint, and then that keys in my head, this side equals that side. I put that equal there. Then I know, okay, well now I've got it set up. So I know exactly what I need to do. I need to set this equal to that, and then I have to solve the algebra. Okay, I have x's on both sides. I need to get them to the same side. So I'm going to subtract this x from that x. Those will go away. 2 minus 1 is 1. And then add that 5 to both sides, because that gets rid of that. So x equals 8. Biggest mistake I see is people stop there. The question is to find the length of PR. I know what x equals, but I need to find the length of this whole thing. So I can plug and find out that this is 11. So this side is 11. Well, they're equal, right? So if this side is 11, then this side is 11. Yep. And that's the final answer. Now, on a test, let's say this was your exact question on a test, and you get this far, you're going to get half the credit. This part would be the other half of the credit. Okay? So but be careful of that. Make sure you're answering the question. If the question says find x, then you can stop there. If the question says find the length of whatever, then you need to find that length. So far, okay? Any questions? Everybody got it? Okay. Yeah, I'm not. All right, the other one we have is between. So I'm just going to do this one right now. I have M is between L and N. So I draw the picture. It's just between. It doesn't say it's a midpoint. So it's not special. It's just some point in between. It can go kind of anywhere. LM is 2x plus 1. MN is 3x minus 2. And then the whole thing is 24. Okay, I know that this plus this will equal the whole thing, right? So I plug in what each piece is. LM is 2x plus 1. MN is 3x minus 2, and then the whole thing is 24. 2x and 3x gives me 5x. 1 and negative 2 give me negative 1. Then I add 1 to both sides, and I get that 5x is equal to 25. I divide by 5. I know that x is 5, and that's all I had to find was x. Okay. So the key to these, if it says between, part 1 plus part 2 equals the whole. If it says midpoint, part 1 equals part 2. And that's kind of your setup on these problems. Does that make sense?